Okay, let's get this started. We're going to talk about parallel lines and proportional parts. Really kind of easy when you really think about it, but today you will use proportional parts within triangles and parallel lines. So the idea here is we're going to use these to do what we need to do. Alright, so let's start off here. We have a triangle proportionality theorem. If a line is parallel to one side of a triangle and intersects the other two sides, then it divides the segments into proportional lengths, or into segments of proportional length. What does that mean? That means this. Okay, this actually makes this problem a little bit easier than what we did earlier in a previous section. Okay, so we had these type of triangles here. Now, before when these were parallel, we had to add those up, find the small triangle to the big triangle, work like that, right? What this one is saying is this. If you have, if you want to find, say, PS here, you want to find that short segment. You don't have to say 7.5 over 7.5 plus 3, like 10.5. You can just say 7.5 and 3, because we have a proportional relationship that looks at just the lines that I'm given. So I can say here, x and 2.5 is the same proportion as 7.5 and 3. Then I can just do a simple straight, cross multiply and divide, and I would get my answer. So that's what that rule allows us to do. Nothing very difficult. It allows us to more easily set up a proportion. But before, in a previous section, we weren't able to do that. All right, here's another theorem. The converse of that. The converse of that says if we take the sides and basically say, okay, the sides are proportional, then we know these lines are parallel. Well, again, what does that mean? Okay, so here's a way to kind of make this question tricky. Okay, in triangle DEF, EH is, I can't read a thing. Oh, EH is 3, and HF is 9. And DG is 1/3 the length of GF. Is DE parallel to GH? So are these two lines right here parallel? Well, yes, they are. So let's look. Okay, or how do I prove that? Okay, so first off, what I always do is try to make sure I write out everything that they give me. Okay, so they told me EH is 3, HF is 9. They also tell you that DG and GF, there's a relationship between them. DG to GF is 1/3. So notice how I did that. They mentioned DG, GF, and I said 1/3, change that to a fraction 1/3. So the theory is this, that if I take EH and HF and set up that little proportion, that ratio, if that simplifies to 1/3, which it does, then I know that the two lines are parallel. If it didn't simplify to 1/3, then the lines wouldn't have been parallel. Easy peasy, right? Yeah, I got this, sir. All right. Let's talk about a mixed segment. I'm going to back this up a bit. There we go. I'll stop right there. Okay, a mid-segment of a triangle is a segment with endpoints that are midpoints of the two sides of a triangle. Every triangle has 3 mid-segments. So in other words, I can do this. I can say here's a point. We'll call it P. And then there's another point. We'll call it R. If I connect those two, and they are creating congruent segments on the triangle, don't go based off my drawing, just go with that. That's called a mid-segment. Now, every triangle has a mid-segment. So you can see here I have PR. I can also find a third point, Q, connected to R and connected to P. That would also make, say, divide BC into equal parts, and there's my 3 mid-segments. So notice how a triangle makes another triangle, mid-segments. Okay, is there a theorem? Why, yes, there is. Theorem 7.7, a triangle mid-segment theorem, says a mid-segment of a triangle is parallel to one side of the triangle, and its length is 1/2. There's the key word, 1/2. So if you are a mid-segment, you are 1/2 of the side that you're parallel to. Okay, so what does that mean? Okay, that's a 13, by the way, right under the Y. Okay, so in the figure, X, Y, and YZ are mid-segments. So I'm telling you, they're mid-segments. Okay. So, what does that tell me? Okay, if I wanted to find XZ. Okay, XZ, quite simply, is parallel to RT. And we now know that that means it would be 1/2 of that side it is parallel to. Obviously, you can tell. So that means it would be 1/2 of the 13, which would be 6.5. That's it. What happens if I go the other way? What happens if I say, hey, this one says xy is 7, and I want to find st? Well, I know again, xy is half of st, or conversely, 2 times xy, because the opposite of multiplying by a half is, the opposite of a half is multiplied by 2. 2 times xy would give me the st. So st then would be equal to 2 times 7, which would be 14. Oh, that is amazing, sir. All right, let's erase that. Okay, now let's look at this. How would I know about the measurement of RYX? So I'm showing you all the different ways I could ask this question. Okay, well, since XZ and RT are parallel, those two are parallel, that means we have a theorem that says alternate interior angles from the transversal of parallel lines are equal. So that means then the measurement of RYX is equal to ZXY. So if ZXY is 124, RYX is 124. And that's it. Pretty simple, right? This looks like an easy section. All right, anyways, thank you so much for your time. How about I give y'all another bonus word? Tortos, since I'm like, you'll see why. Anyways, that's it for today. Your bonus word again was tortos. Thank you so much for your time. Y'all take care.